Today, I want to speak with you about some topic which a bit slightly different than what we are discussing from the morning, which is about the rapid construction or the construction speed. I want to take you with me today in a thinking journey and try to explore what's behind this construction speed. But before that, I want to explain from where the idea comes. Actually, before even COVID started, there is a lot of reports saying that we have a shortage in the housing sector, housing project, against the demand, especially if we talk about the affordable housing and the low-cost project. And now with the slowdown happened with the COVID, of course, this gap got increased. And hopefully we are looking forward to the end of this era, so we should recover. And to recover, we need to build faster. And speaking about the construction speed here, there were two cases came to my mind when I was thinking about this topic. First, about one of our clients approached us for an affordable housing project in Dubai. Yes, affordable housing project in Dubai. And the client, it's a kind of social project, and the client have certain target rate per square feet in his mind. And if the project could not meet this target rate, the project lose its economic value, and then the project will not happen. We think a lot, and we try to find a way how to reduce the cost, looking after specification, optimization, vendor list, looking after material in China, everything could save the cost. We couldn't match that target rate, and the only way we could reach up to that target rate is by reducing the construction duration, to build the project faster and cut from the peak of the prelims on the project deployment. Another case we have when also another client approached us for another a factory project. This factory to produce certain product in response to a market demand in a certain time. If this factory is not operational within a period of 7 months, from start of the design to completion and commissioning and start production, again, the project lose its commercial value, and it's not gonna happen. Then again, here, it became evident that the cost is definitely relevant to the time frame. And for me, as a person who is always evaluating the risk of construction, all the time we look on the construction duration, and this is one of the biggest risks. If we are not able to fit within the client demand, then we are report to our management that we have a risk here. Of course, there is a hammer on our head always about the LDs, and we have to be careful about that. This creates some kind of contradiction in myself. We need to build faster, but are we able to build faster? Can we really do that? Now, to answer this question, I come along with a two case study. One of them about the Empire State Building, and the other one about the hospital, the 10 days hospital in China. And interestingly, these two projects, even as I selected, it has a huge contradiction in between. First one is a high-rise or a super high-rise. The second one is a horizontal project, one from the west and one from the east, and one from almost 90 years now, and the other one just a couple of years back. With this huge contradiction between, I will look on these extreme cases, and as a disclaimer, I'm saying those are extreme cases, and I have a purpose to choose extreme cases. Let's start by the Empire State Building first. This project has been completed in 1931. And it's not actually a small one. It's almost 208,000 square meters, and it was the first building to exceed 100 floors in terms of height. The height of the building is 443 meters, including the pinnacle in the top. And this building stands as the tallest building for almost 40 years, 39 years exactly, until 1970, and then the World Trade Center take the place. I have the experience in thinking about beyond a reference project, and if we talk about a building need to be a highest in the world, there are always a lot of consideration where you don't have a benchmark to compare. You don't know what will happen. Maybe these days we can simulate using some computer softwares and some kind of technologies, but at that time, this technology was not there. Actually, if you look on the program of this project, which was the highest, and it's exceeding a 400 meter, this bar chart, which you can see on the screen, is already put there inside the observation lobby on the top floor. At 13 months, from the groundbreaking up to the completion of the project until it starts getting occupied. They reach 4.5 floors per week. Today, if we complete a floor in 3 days, or let's say some groundbreaking, maybe some breaking rules up to 2.5 days, they manage 4.5 floors a week. They complete the project at the end 3 months even ahead of schedule. And not only that, they complete the project $9 million under budget. That was 20% of the estimated budget for the project. In today's money, after the inflation and everything, this is around $100 million saving from the budget. It's a steel framing, and from day one, once they start thinking about this project, they decide that they need to build it fast. So they take all the measures which they want to take in order to deliver on the time, including designing rest area and minimizing the labor movement and designing a railway around the project to move the material around. At the end, they reach a peak of 3,400 labors per day, and in the total, it's 7 million man-hours. Of course, this project got a lot of criticized for the safety. When they want to talk about the safety, they put those photos for those laborers sitting on the beam like that. The official records say that there were 5 fatalities, although there are some unofficial records of 14 in some reference, and I find another one talking about 42. Even one is not acceptable, but here, what I want to say is the fatalities or the safety problem, it was because lack of awareness. It's not because of the construction speed. So that was 90 years back. So how about today? I'm pretty sure at the beginning of the COVID, we all follow up these 2 hospitals which they built in China, in Wuhan. One of them was slightly bigger, and it took 11 days, but today I'm talking about the smaller one. And this smaller one is 60,000 square meters, is designed for 1,000 beds. And this project completed in 10 days, again, from groundbreaking to complete commissioning. Now, before someone starts criticizing me, I want to put this disclaimer on screen first. Yeah, I know it is an exaggerated project. We need to know that it was a national project. And this national project means the entire government, the entire country is behind this project to be completed within this time frame. It used a pre-approved design, pre-approved system. There was a pre-approved plan for this project to be executed within such kind of a quick response. And they use a reference case of another hospital which they built in Beijing at the SARS time in 2003. Of course, with alteration of design, but the pre-plan is already there. The third one, they use an off-the-shelf pre-approved system also. So the material, when they decide to use, it's already available with many vendors and with many supply chain. And the last part, it is a temporary construction. It was not intended to be living for a long time. Actually, the hospital itself has been decommissioned after 2.5 months from operation because, of course, the case went down. The point here is, as per the regulation in China, the temporary construction should be not less than 5-year design life and should not exceed 10 years. So those 4 items of disclaimer we need to put in our mind before we start exploring this. Now, the site condition, it's 50,000 square meter site. It's 150,000 cubic meter of excavation work. The site has a 10-meter difference between one end to other end as a level difference. And there was even a fish pond over there which required to be backfilled before they start the work. There is only one access from one side. The other side, it was not having access. And there were, for the earthwork, they require 400 workers and 300 machineries to be engaged in 24 hours. If we talk about the manpower, the initial estimate, they expect around 7,000 laborers need to be deployed for this project, plus 1,000 equipment. Now, I don't know if you are familiar with China or not, but once we come close to the Chinese New Year, everyone go in a big holiday. And this is a serious holiday. So eventually, that was the time of the Chinese New Year. It's not only that, but also Wuhan, which is the city where this hospital built, has been completely locked down. So the government there, they boast something they call the hero boasts, is calling for volunteers from across the entire country to come and contribute for this project at all levels of the supply chain. At the end, what they end up, they have more than 7,500 laborers on site during this time of the 10 days for 24 hours operation. That's, of course, along with 140 numbers of the management staff. They use two systems. It's a prefabricated system, but they use the system in two ways. One way is to use the individual element as a 2D panel. This was spoken in the previous panel, so column and slabs. It's all a lightweight members, which can majority of them used only with the hand without using the equipment. And the other way around is to use the volumetric, and the main reason for combination is because the site has an overlap of activity, so they allow some of the production to be done in the factory while some activity is going on the site, and this is to maximize the efficiency. Of course, there is no room for failure. It's a project which the entire world is monitoring, and it's a quick response to the pandemic. There were 100 of specialist subcontractors engaged. This is a hospital. And the equipment which need to be deployed, it's a huge number which they have to work together safely and orderly. Now, we are talking about something happening on the time where we have a pandemic. At that time, information is very limited. We don't know what's the extent, how it's getting transmitted. This hospital is going to combine between the sick people and the healthy people. And we need to make sure that even from the design and construction, this cross-contamination should not happen. The main focus is there is also about those workers who are building this hospital, how to keep them safe. At that time, again, it's too early to know how to control this pandemic, how much the safe distance we can keep. Today, talking about 1.5 meter, 2 meter, at that time, no one knows. No one knows even it's airborne or it's other way of transmission. All these challenges has been put together. These are the activities day by day. If we can look on the earthwork in the first day, in the foundation, the second day, there was a mock-up still going on, and the activity went day after day. Maybe we've seen some of these videos at that time, but still good to refresh our memories.
晚上3点钟，我们的管理人员就到位了，然后我们的施工机械都是早上5点钟、4点钟到5点钟拖到现场。
预放楼。
You can notice the dates day by day. Okay, so what I'm promoting here, what I want to say, am I going to promote building hospitals in 10 days or building tallest building in 1 year? Actually, no. I put these two case studies in particular just to look on the extreme and try to explore, because once you put an extreme case or exaggerated case, then the key factors became more obvious. So if we want to build quickly, now we can build quickly because it has been built in a quick way, but not with the practice which we are doing today. So I came up with some ideas, which again is part of my thinking journey with you, based on analysis of these 3 case studies, for some holistic approach, which if has been undertaken and implemented, we are able to improve our current practice of construction. So 3 key elements we have. I will talk about the efficiency in non-construction activities, the resource planning and monitoring, and the engaging of emerging technologies. They say don't reinvent the wheel, and in fact, we are reinventing the wheel in each construction project we are doing on a daily basis. We're supposed to know what we are doing because we are doing this for so many years, and eventually every project we are doing, we are going through the entire same process of design and design approval from the beginning. Imagine that every time we need to submit a mixed design for concrete, and this mixed design has to undergo through testing, cube crashing, and we have to wait either 28 days or 56 days until we certify this mixed design can be used or not. A couple of years back, I've been in a visit to Serbia. Over there, they have only 6 mixed designs across the entire country. And these mixed designs are the only one approved by authorities over there. All the suppliers know this mixed design. Consultant has to use this mixed design in their design. So there is no mixed design approval. In a special case, yes, we can make a special mixed design, but how many projects we have require this special case? Believe me, more than 90% of our project does not require this special case. Think about this approval process. We are spending a lot of time of writing codes, and we give these codes for consultant engineer to do the design. Then this design needs to go to authority to approve it. No. Before we go to authority, then a third-party checker needs to check it. Then go to approver. Then the authority once approved, does the authority take the liability of the design? No. Liability of design will remain with the engineer who did the design at the beginning, although 2 people check after him. Then good, we have the design approved, we give to contractor to start building. So can the contractor start? No. Contractor still has to develop shop drawings. And this shop drawing has to go back again to engineer to approve it. And he has to wait. And does the approval of engineer is relieving contractor from his liability or bringing back the design liability to consultant? No, still that accuracy of this shop drawing will remain with the contractor. So what we are doing here, how much time we just wait on a process which went through 5 times of reviewing until only we can start construction. Actually, if we talk about waste management in construction as a whole, we need to look on the waste management of the process because there is a lot of redundancy and there is a lot of part of the processes and steps which can't be safely added. And believe me, it's not happening everywhere. In many countries, this concept of shop drawing approval is not there. In many other countries and even nearby countries, that authority review for the design drawing also is not there. So this is something here which we need to look into. We also need to consider this approval process, and sometimes we don't know what we are waiting for. For example, we use the mock-up in many cases to confirm and validate the design and for material selection and for colors and so. Mock-up is only for workmanship. Any matter which introduce a holding point need to be eliminated if we want to build quickly. And we need to consider that seriously. We need to define responsibility. Everyone knows what he's responsible for, liable for, and then cut out all the holding points. This is about the efficiency of non-construction activities. This is actually my call to developers, to consultants, and authorities. My next point is my call for my colleague of contractors, is about the resource planning and monitoring. There is a misconception about the resource deployment, and if a woman can deliver a baby in 9 months, some people think if you bring 9 women, they can deliver in 1 month. It's not gonna happen that way. Even I don't like the idea itself. Actually, it's about how to utilize the resources in the proper manner and in an efficient way. We need to put the right resources on the right time. And the right time to inject resources is when our learning curve is increasing. And if the resource efficiency is not really bringing what we are looking for, we need to question the method. Is it the right method or not? And also we need to question the sequence. Actually, the prefabrication is a great advantage of shifting the sequence out of the critical path. The main point here is resource saving or resource efficiency need to be on a win-win basis. It does not make sense if we need to build it quickly and there are some people who have a different conflict of interest because they need to be deployed in the project for a longer time. So it needs to be on a win-win basis so at least everyone would be beneficial from the time saving at the end. And 3 main areas where we can deploy technology. First one, automation. Automation can be in non-construction activities, and we have a good technologies for that, especially for design reviews, design validation, progress monitoring, and control. And for the construction activity itself, which is the exercise for this industry for the next 10 years, mainly for the robotics, 3D printing, and others. Second area, I think we speak enough today about the off-site fabrication, and which could be partial, as a precast, boards, or maybe MEP modular, or as a whole, volumetric or a 2D. Digital transformation, I believe what we have today is even ahead from our implementation, but we are not using it correctly. Talking about the BIM, the common data environment, blockchain, artificial intelligence, I think we have covered this more than enough in today's event. These are the three areas where if we put efforts and we put our endeavor together, we can build quicker and we can achieve the cost and quality values coming out from building quickly. This all has definitely to work within the environment of a green construction, otherwise we are stepping backwards, not forward.